Hey AP, in this video we're going to talk about os.path and everything to do with file paths on your computer. You probably won't get a ton of questions on the MTA about this particular library, but if you've never seen anything with it before, it could be kind of confusing or intimidating to look at. It's pretty simple. We're going to look at the simplest ways that os.path is used in a Python program, so let's get started. So the first thing I want you to notice is that on the left side where I have my files in Replit, I have created a text files folder and a bananas.txt text file with the word banana in it 3 times on 3 separate lines. What I'm going to do next is bring the library in that I'm going to use. So I'll import OS and I'll run this. When I import OS, it gives me access to all the methods and attributes of the OS library, obviously. One that's valuable for you to see, and I'll zoom in real quick, is os.name. It's useful to know the name of the operating system I'm working on in any given context. In this case, this is a POSIX system, which ultimately means that it's Linux-based. If I come onto my computer and bring up the Python shell, and I type in import OS and os.name, I get NT, which means it's a Windows machine. If I were on Mac OS, I would get Mac OS. So knowing the name of the operating system is important, but at the same time, what os.path will allow me to do is write code that works on all operating systems without needing to know what operating system I'm working on. In fact, it will do that for me. That's extremely important because we need our code to run on a variety of systems without a bunch of special stuff in place to make sure it works for that particular OS. Let's assume I want to do some kind of work with the bananas.txt file. As you might recall from read-write, we need to use the with open, give it a file name, and say as f. So now we're going to be working with this open file as f, and then we can do something like printing the output of read lines. Now you might know that this is not going to work because there is no file called bananas.txt in the same directory as main.py. Main.py goes out and looks for bananas.txt somewhere and does not find it because this file is nestled down inside this text files folder. So what could we do? First, you might remember that we want to move this literal string outside of the open call and bring it out as a variable. And the reason for this will become more clear as we continue to work with os.path. So I'll type in text files / bananas.txt, and we'll see if this works. I'll run it again, and it does. But wait a minute, I've got a / here. What do these file paths look like on my Windows machine? Let's take a look. Let's look at my folder, and then I highlight this. Notice that the slashes are in the opposite direction. So if I were running this program or building this program on a Windows machine, this actually would not work. It would give me an error because a Windows machine uses backslashes. This is where os.path really shows its strengths because we need a way of writing code that will work on any operating system regardless of whether or not it uses / or backslashes. Let's look at that next. So we will accomplish this OS agnostic. Agnostic is just a word that means it doesn't matter, like it's irrelevant in a way. So OS agnostic file path can be accomplished doing this. So we're going to say os.path.join. Kind of like the join method with strings, but it's a little bit different. Okay, so we're going to say os.path.join. And how does that work? Well, we need the directory that we want to join to the file name we want to join. In this case, it's bananas.txt. So now, if we run this code again, we'll see that file name will be the correct version for the operating system we're on, which in this case is a /. If I go back and do this in Python, I could say, let's see, we'll do os.path.join Bob with corn. I don't know. But notice that now I get this different output. I get 2 backslashes, okay? And that is basically the same thing. It's Python interpreting what is necessary for my operating system, okay? So when we write paths and want to put them together, we don't use the actual slash character. We're going to use the join method always. This builds our file path for us. Sometimes it's also valuable to be able to pull the full path of this file no matter what. So let's look at this. os.absolute_path of bananas.txt. What did I type wrong? Oh, whoops, not os, but os.path. I'm glad you saw that. So os.path, remember that path is a sublibrary. So say os.path.abspath bananas.txt. Well, what is this? Notice that home and runner are not over here, right? We can't see those. These are actually REPL folders that exist for every REPL we create. And notice that OS examples, that's actually the name of the REPL. So this is the full file path to bananas.txt without my text files folder. And I'm not sure why that is exactly. Let's look at an example in Windows just to make this clear. I don't know why it takes out that text files folder. It must have something to do with the way REPL works. Let's look at a real Windows example real quick. So I'm on my Windows machine, and I'm in this folder where I've got some review code for object-oriented programming, right? Well, what if I want to know the path to get to this file, kb-basic.py? What if I need a way of knowing where that is on my computer no matter where I am in my file structure? It's really important to be able to do that. So if I type in Python and I say import os, if I say os.path, or os.path.abspath, and then I say kb-basic.py, notice that I get this huge file path. And what that is the full or absolute path to that file. So typically, when I am referencing a file on a system, I want to use the absolute path because it means no matter where my code is executing, I'm always going to be able to find that file at the full absolute path for where it exists, okay? It's kind of like if you have a map, right? And you have like a local map for Louisville, Kentucky, right? If I'm in New York City and I'm asking you, the person living in Louisville, what the directions are for the, Circle K that's around the corner, you have a really good idea locally of where that's at as a person that lives in Louisville, in that neighborhood, right? But if you try to tell the New Yorker the same path to get there as you take, it's going to be totally incorrect. The New Yorker needs to know to get in his car and drive all the way down to Kentucky, take this expressway, get on this sub road, and then get on, take whatever turn to Circle K. Like, they need the full path to that Circle K, whereas you can work with a local path. But we always want to give our computer the absolute path. It makes it much easier for it to find stuff no matter where we're executing our code. So back in our REPL, the way we will make sure that this path that we're putting together through join is always a full absolute path is by saying os.path.abspath, and then we just surround our join with that right there. And if we run this code, we say file name, we get this full absolute path. And now the text files is there. I don't know why it wasn't before. But this will always work. It will always find bananas.txt if it's there. The next thing that we need to check is if bananas.txt actually is there, okay? So that brings out another cool feature of os.path. And so what we're going to say here is if os.path.exists, and then give it file name, right? And then we'll do this operation. So if it doesn't exist, what are we going to do? We'll say else print file not found. And you might think to yourself, oh, isn't there a file not found error as well? Yes, and you could do that too. You could create some exception handling right here. So let's run this code. We get banana, banana, banana. Let's make a change. Let's type in strawberries.txt. Now you can see, oh, file note found. File not found. So in this case, path exists, lets us know, does that file even exist? Obviously, before you execute a bunch of code on a file, you want to know that it exists. If it doesn't, you're going to be wasting your time and running into lots of errors and giving your user a headache. Okay, let's look at a couple more things. So, we also might want to ask, is something a directory? Now, I'm not going to go into the detail of why we would ask if something is a directory. Actually, in APCSP, we're going to talk about recursion, and we're going to look at a practical example of recursion using os.path.isdir. But in this case, we're just going to see what it does when we use it. Okay. So what we're going to do is we'll come over here and we'll say os.path.isdir file name. False, right? Because file name is a reference to bananas.txt. If we say os.path.is file name, it's going to tell us true. Okay, so that's essentially what you need to know for os.path. If you're thinking, you know, like what's up with the isdir is file thing, just think of it this way. Like if you only want to execute some code on a file or run a certain file using Python, you don't want to try to run a whole directory. What would you do if you ran into a directory? Well, then the logical thing to do would be like, okay, well, is the file I want to run inside of that directory? So if it's a directory, you might go further down and see, like, is the next file I've looked at a directory? Or the next thing I've looked at a directory? And then I would keep looking through the directories until I actually found my file, which I would check with is file. Okay? So that's os.path. Again, it's pretty straightforward. These are really the methods that you'll need to know for the MTA. I would encourage you to take some time to try to work with files on your own computer or build a little file structure like I did here in Replit and try this stuff out on your own, okay, using the documentation. That's it for OS. I'll see you next time.